My name is Gary, and I'd like to thank you all for attending Colorlight online course. This is something new that we were starting to do. We think this is an effective way to help a lot of our customers or potential customers better understand what Colorlight is. Let me go over a couple of basic things while we get started, just to make sure everybody is on board. My expectation on this demo is we're doing roughly 40 minutes to maybe 50 minutes demo, depending on the type of questions get asked. And then we will leave the remaining time for answering some of those questions. We want this to be as interactive as possible, although everyone should be muted. I want you to definitely feel comfortable asking questions by using the chat section on Zoom meeting. I want to tell you we will take your questions and try to get them answered in the real time. We've got a team of our engineers that are ready and willing to answer any questions come across the chat. You can also, if you want to get more details, by all means, send us questions to gary@lednets.com. And lastly, give us feedback. Let us know what you want to hear. Let us know what you want to see in other demos, so that we can continue to improve and make this better. Okay, so let's go ahead and get started. So today's course, what we're going to talk about is the iSet software generalized functionalities. And in the end of the course, we will review some of questions get asked in the chat section. iSet software is a service and install tool, very intuitive interface designed for Colorlight S, X, and Z series processors. Each processor has different capabilities, but ultimately all run the iSet software. Whether you are integrator or end user, the software will help you to build your LED wall easily and efficiently. You can download the latest version from our website, www.colorlightinsight.com. The software can only run at Windows platform at the moment. It's compatible from Windows XP to Windows 10. Its minimum requirement for the hardware is listed on the right of the slide. This is the default user interface when you first time open iSet. Please notice that the UI might be looking different depending on the type of processor iSet is detecting. There are mainly three sections. The tabs on the top is where you can switch between different functionality sections. Click the iSet logo on the top left to get into software setting menu. The rest area is where we can do specific settings to the LED wall. This section appearance will change when you switch tabs on the top. Before we get started, I wanted to explain our demo setup here. We've got a small 4x2 demo LED wall driven by a X16 processor, and a web camera has been set up in front of the demo wall, so that you will be able to see the LED wall's reactions to the change that have been made on iSet software in real time in the camera window. This is the camera window. If you're using a computer watching this, you can resize the camera window in case it's not big enough to see the details. If you're using a cell phone app, you can tap on the camera window to switch back and forth between camera view and iSet. Let me drag the iSet software to the share screen. Hold on a second, please. Here we go. You're now presented with the default user interface. The first thing to do when you set up your screen and the processor, we want to check whether there are any problems between the processor and the LED panels. So let's start by looking the first tab from the left to the right, which is device information. Device information is where we can detect senders and the receiver cards. Please notice that the sender also refers to as processor. Click Detect Senders button to check whether the USB or LAN connection between processor and the computer is okay. If everything is good, you'll be able to see the sender type and the firmware version. We're using X16 processor right now, and its firmware version is 2.6. Click Detect Receiver Cards to check each receiver card type. I9, firmware version 2.01, and the LED panel temperature if you have a temperature sensor in the panel. In the meantime, if you look at the sender information section on the top, you will be able to see the number of receiving cards being connected on which processor's output port. In this demo, we've got 8 receiving cards, 4 on port 1 and another 4 on port 2. If there is a connection error between LED panels, you will be able to see an error sign show up in the cable column. This is indicating the bit error ratio, not disconnected cable data cables. If there is a disconnected cable, you would totally not detect any receiver cards of that cable. So bit error ratio is actually the number of the job packets in the data cable chain. A bad connector, unqualified electronic parts, would cause high bit error ratio. From LED walls perspective, high bit error ratio might cause flashing or pulsing. The bit error ratio will be also increasing by time. We can right-click on the cable column to reset the cable status. It can also filter all failed cables by checking this box. So the users will be able to easily and quickly identify where the cable problem is. The last column is the amount of time that your LED panels has been working. The timing will be reset if power cycle the LED wall. Next up is Video Source Settings tab. This tab only shows up when you have X or Z series processor connected. Single click on these small buttons to switch between the input sources. Under these buttons is the input video setting table. We can see how many types of input ports on the processor. And if a port is activated, we can read its information such as resolution, frame rate, and bit depth. In the cropping column, we can click here to remove unwanted area from the input video. This can change the input video's aspect ratio. And stitching the images together if you have multiple processors, daisy chain. If the software is detecting external clock reference, it will be showing on the left box over here. And use the drop-down menu next to it to choose the reference signal, either genlock or any input of the processor. Click window count, drop down bottom to start a picture-in-picture setting wizard. Say we do 3 peaks. Set the first window. Sorry, 2 peaks. We set the first window, HDMI. We can set the resolution and the starting pixel position, which represented as X and Y coordinates. And it goes to next. Select the second window as DVI1. Still, we can resize the window by typing numbers in this box. And finish. In picture adjustment, we can globally configure your LED wall hue, saturation, brightness compensation, and contrast. There are 2 ways to scaling your input content on the LED wall. Either type in the resolution and the starting point, which represented as X and Y coordinates, or hold and drag your mouse on the edge of the content canvas to resize it. Each window can be freely resized and placed onto the LED wall. If you look at the camera window, you'll be able to see a black box on the screen. That's the DVI. Let's move on to Design tab. In Design tab is where we can create LED walls mapping. Create a mapping is essentially draw the cabling on the canvas according to the actual LED panel connection order. The first step, toggle OSD, on-screen display. If you look at the camera, a number shows up on each LED panel, which represents the wiring order of each screen from the output port. In this demo, we are using port 1 and port 2 on the processor. Click Add Cabinets button. Please notice that cabinets also refer as to LED panel or LED tile. And select the panel we will be using. In my case, I have chosen custom cabinets. Type the right resolution, 176 and 176. This is the resolution that I'm using. Then place the panel on the canvas. Hold your mouse and drag. Then release the mouse button. Do again for port 1. Add a cabinet, custom. According to the OSD, obviously, the 4 panels driven by port 1 is on the bottom, and the other 4 panels on port 2 is on the top. And the cabling order is coming from the left to the right. There are many cabling options here on the right side. We can select the right one from the left to the right. Or instead, you can use the tool on the top to manually draw the cabling. Let's clear this cable, this mapping first by clicking Clear Mapping. Use this pen tool to manually draw the mapping from left to right. And then click on the blank area on the canvas to escape. If you already have configuration files, also known as RCVPP file, which usually created in the factory, they can be saved to the iSet by clicking on Type Management. We can create groups in Type Management, and on the Groups folder, we can add your configuration file, which is RCVPP file, by clicking Import Type. This is the configuration file for the demo screen we are using. Open. We have already added this configuration file to the iSet software, which is demo 3.91. And then we can add the cabinets by choosing the configuration file from demo 2, demo 3.91. Same procedure. Place on the canvas, hold your mouse and drag to create the mapping. We can right-click on the cabinets or the center tab. Select cabinet parameter and save configurations to save the RCVPP file through iSet to the LED panels. It's going to take a few seconds. All right, it's done. And let's keep look at some other features on the software. In the bottom of the right side, these little bars indicating the remaining capacity of each output port. Make sure they're green. If it's red color, it means that port is overloaded pixels. Port 2 is overloaded. In the iSet software, it's also very easy to set up a redundancy. If your processor has got a spare output port, you can use these ports as a backup. I'm using 2 ports in this demo, so we've got 14 spare ports. Just right-click on the port you want to use as a backup. In this case, I'm using port 3. Right-click on port 3, go to port backup, and select port 1. So now port 3 is a backup of port 1. If you have a spare processor, you can also set up a spare processor as a redundancy with a few clicks. It does not matter you set a redundancy port or redundancy processor. Once it's been set up, you will see a little redundant sign on the cabinet itself or on the port. This sign means the redundancy is activated. We will cover more details of redundancy setup in our future courses. So let's look back to the toolbar on the top of the software. Click the finger button to highlight your panel on the LED wall. You will be able to see a flashing box on the panel you highlighted. And if the panel has got an indicate in the back, the indicator will be flashing different than others. Could be flashing fast or changing the color. This feature significantly facilitates the field engineers to do on-site troubleshooting. We could also print the mapping by clicking this print. The mapping is showing the cabling resolution, designer information, and etc. You can even change the order marker. As you can see so far, iSet software is not a control software. It's also a design tool. There are many other useful functions in iSet, which will make your life easier than ever before. Due to time restriction, I cannot demonstrate all of these features in this course. But I want to encourage you to ask questions in the chat window. Our tech team is standing by. Then the tab next to design is control tab. In the control tab, we can set the LED overall brightness, color temperature, and the record test patterns, freeze the screen, black out the screen. Brightness, color temperature, test patterns, freeze the screen, or black out the screen. I also would like to point out iSet can group processors and output ports. With this feature, the user will be able to control brightness separately per port group or processor group. In this example, I'm setting port 1 to 3 as a group and port 4 to 8 as another group. We can adjust port 1 to 3, 70% brightness, and port 4 to 8, 30%. So this feature provides the processor or the software to control multiple screens connected to one processor with different brightness. There are 3 hidden tabs for advanced users. Click iSet logo on the top left to enter the software setting menu and go to advanced authorizations. I guess I have already enabled it. So let's skip this procedure. Directly go to settings. Software features. You can check show advanced soft edge, show color and brightness, and show monitoring. Okay. After that, we're gonna see 3 more tabs shows up on the top. Except advanced tabs, there's something else we can have a look in the software setting menu. Multiple languages, including Chinese, English, French, Japanese, Spanish, Korean, Portuguese, and Russian. Click Tool to get into the port loading calculate, which help users to calculate number of pixels that an output port is able to handle in project design. And if we go to Help option, we would be able to see the software user manual. You don't even need to download a manual from the website. Let's go to Advanced Soft Edge. Soft Edge is also known as seam correction. Seam programming could cause bright line or dim line between modules or cabinets if they were installed too close to each other or too far away respectively. This is a very common issue in small pitch screens and rental projects. Sometimes we don't have time, tools, or necessary environment to calibrate the whole screen with camera. Soft Edge can fix those problems manually in real time with an intuitive user interface. This process is effective and fast. Simply activate Soft Edge. Go to Seam mode. Your screen will turn to white to let the users can easily identify the gaps or the seams on the screen. Use this crosshair to locate where the seam is on the screen. And click on the areas between modules or cabinets. And then select whether to change the brightness up or down. The screen will take effects immediately, in real time. The software will brighten or darken the pixel directly along the seam, giving the illusion of the module or cabinets being closer or farther apart. But in the real world, the physical gap between modules or LED panels is not always aligned. For example, hang on a second. The gap on the top is wider than the bottom, would cause the same top is darker than the bottom. We can click this plus to add more brightness in the top and less brightness or reduce brightness on the bottom. To make your screen looks like more flat and uniformity. And after that, we can save edge coefficients to the LED panels. With advanced soft edge, the seam correction data will not travel with the LED panels. We can easily reset all the edge correction data without affecting the calibration data in the module or in the receiving card. All right, let's take a look with the color and the brightness tab. See what we can do in this tab. Always read the screen information first. We can select the solid color to display on the LED wall so that we can easily notice the color difference between panels, LED panels. Look at the canvas on the left side. There are 8 panels in total. The left 4 panels background color is different than the right ones. This represents they are coming from different batch, which essentially means their color space are not the same. Color space is the amount of colors that your LED wall is able to display. We usually use color meter to measure LED screen's color space. Go to Original Color and Brightness tab. Select the panels we're going to adjust. If you have a color meter connected to the computer that is running iSet software via USB cable, then press Chroma Meter Measurements button to start measuring color automatically. iSet is able to communicate with several types of color meters. If we place the mouse on this button, we would be able to see the model of color meters that iSet software is compatible. Otherwise, you will need to manually type the measurements or coordinates in these little boxes. Or you can import a configuration file or export the configuration file. The measurements determine the triangle size on the left. The more colors your LED panel is capable, the larger triangle in the left. As we know, these 8 panels are coming from a different batch. We select all panels by Control A. Enable adjustment. And then we can select multi-batch adjustment. We can see there are 2 triangles on the left. Each triangle represents 1 batch. The software can auto-calculate their color space and take the common color space both batches can hit and apply to the LED panels to make the screen display uniform color and brightness. We can also set LED panels to a particular color space to meet the user's requirement as well. A good example would be using LED wall projector together for a presentation at a conference. Definitely the LED wall and the projector's color would be not the same. In this case, we would use advanced adjustment to precisely set up a target color space to match the other displays. We can either drag the triangle on the left to change the targeted color space, or we can type the coordinates in this table, target color space table. Also, there are multiple preset color space, standard color space, such as Rec 709, Rec 2020, DCI-P3, and Adobe RGB. We're choosing custom right now. If I change the values in the custom, in the targeted color space table, the triangle on the left will simultaneously change its size to let the users which is the right direction to go. There is a small table on the targeted table. It's actual color space. Sometimes our screen's original color space cannot hit the targeted color space, so the software will auto-calculate to take actual color space and apply it to the LED panels. We can import and export all these color space parameters to a computer or from a computer, a local computer or local disk anyway. And finally, the last tab we're going to go through is monitoring. There are many things we can monitor over iSet. Let's go to the monitoring settings tab first. So we can monitoring the video signal, screen freeze alarm, black screen alarm, and zero brightness alarm. We could also monitoring the temperature, the humidity, power supply, and the voltage of the power supply. And we can add the email alarm to receive notifications if, say, a temperature over a chosen value. So the software will send you email notification to alert the users there are something wrong with your screen. And we could also set up the video signal monitoring. And then after we set up the monitoring parameters, we go to start monitoring. After we start monitoring, you will see a tips window on the top right. It says abnormal is detected in monitoring. I guess it's because the video input. We are now only connecting HDMI input. So there is no cable connecting to DVI and SDI. But I have already enabled those inputs monitoring. So the software is alerting the users DVI and SDI are not connected, are not receiving any video signal from the source. We don't have a temperature sensor in the panel, so there is nothing displaying in this tape. Also, we don't have a humidity sensor in the panel. And if you want a voltage monitoring or power supply monitoring, you have to choose a power supply that is capable of output monitoring signal. Alright, due to the time, we're running out of the time for today's course. We will cover those points that we were unable to explain in other demos or other classes. In the remaining time, we will take a few of our questions and get them answered. Please raise your hand on the software so that we can unmute you.